And now we have question 12, which says to solve this quadratic equation using completing the square or the quadratic formula. So you could either use either one, whichever you prefer. I'm going to solve it using both, just so you can see it whichever way you attempted to help you identify your mistake. So there's completing the square. So if I'm going to solve this using completing the square, I am going to first take this equation and I'm going to ensure that my A term and B term are on the left and my C term is on the right. So in order to do that, I'm going to take my x squared plus 22 equals negative 10. And I'm going to ensure that that A term stays positive, I'm going to take this 10, I'm going to move it over to the left. So this 10x, sorry. And so I have x squared plus 10x plus 22 equals 0. Again, I'm completing the square. So I need this 22, this c term, out of the way. So then I'm left with x squared plus 10x equals negative 22. Then, to complete the square, I need to take this 10 and I need to half it and square it. So half of 10 is 5, squared is 25. So then once I have this 25, I'm going to complete my square. So to complete my square, I add 25 here, and I add 25 here. So I'm left with x squared plus 10x plus 25 equals 3. So then, now that I've completed my square, I know that this will factor into a perfect square term, x plus 5 times x plus 5, or x plus 5 squared equals 3. I take the square root of both sides. Don't forget that it's a plus or minus of the positive or negative square root of 3, because when I take the square root of both sides, I have to have positive or negative, because the value inside of this could have been positive 3 or it could have been negative 3. So positive square root of 3 or negative square root of 3. So then I have x plus 5 equals plus or minus square root of 3. I subtract 5 from both sides, and I have x equals negative 5 plus or minus square root of 3. So that would leave me with answer choice B for negative 5 plus or minus square root of 3. Then I can solve this same question using quadratic formula to show you both ways. Remember, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then, x equals, I could take this same equation, I solved it over here already, but it would give me x squared plus 10x plus 22 equals 0. One of the big differences between completing the square and quadratic formula is that completing the square, you want your c term out of the way. So you want it ax squared plus bx equals negative c. You want the c on the other side. But for quadratic formula, we want ax squared plus bx plus c equals 0. We want 0 over here so that we have our full value of our coefficients. So for this, a is going to be 1, b is going to be 10, and c is going to be 22. So then when I substitute in my values, I get negative b, which is negative 10, plus or minus the square root of 10 squared, so 100, minus 4 times a, which is 1, times c, which is 22, divided by 2 times a, which is 1. So when I simplify this down a little bit, on the inside, I have 10 squared, which is 100, minus 4 times times 1 times 22, which would be 88. So 100 minus 88, which is 12. So I have negative 10 plus or minus the square root of 12 over 2. Now, none of my answer choices look like that. So I must need to simplify a little bit more by taking that 12 and simplifying it down. So I know that square root of 12 is the same thing as square root of 4 times square root of 3. Well, square root of 4 is 2, square root of 3. So square root of 4 is 2, and then just bring down your square root of 3. So then I have x equals negative 10 over 2 plus or minus 2 square root of 3, which I'm going to put in the place of 12 because I got that over here from simplifying. 2 square root of 3 over 2. So then negative 10 divided by 2 is negative 5 plus or minus 2 divided by 2 is 1 square root of 3. So I don't have to put that 1 there because 1 times anything is just itself. So either way, no matter which way I solve it, I still get negative 5 plus or minus square root of 3. Now, just a hint on this one. One of the reasons that it's asking you to solve using completing the square or quadratic formula is because this one would not necessarily be easily factored. If you're trying to think of what could multiply to give you 22 and add to give you 10, you may not be able to think of factors there that would work. So 22 would be like 2 times 11, and that's really all you could get. So this one could not be factors. That doesn't mean that there's no solution. It just means that you'd have to arrive at that solution some other way. And when there's a radical still in here, we're not going to get that by factoring. We would have to get that using completing the square or quadratic formula, using one of our other methods. So that's just something to keep in mind for this one.